Okay, we're going to try this again. I'm making a new video for you to watch. It's just a quick practice problem, but first I want to show you this cool little fizzlet. And so here's the idea. This is a photon, and this is your electron, and I have it set up right now to be on the same level, and watch what happens when they play. So the photon hits the electron, and you can see the electron was given some energy, and the photon scattered back. That's kind of cool. All right, and then let's just move it up a little bit. Maybe not that much. Move it up a little bit, and you're going to see more of a deflected angle, right? So there goes the photon off like that. And maybe even just a little bit less. Okay, that's kind of cool. Oops, sorry. Pause, reset, and let me see what happens here. I might miss it altogether. I haven't played with this one. Okay, yeah, that wasn't exciting. It misses it altogether. All right, we'll try it one more time. And then it goes off at an angle like that. But watch, I mean, this just only gets a little bit of energy, right? But it gets some. Okay, so that's worth kind of playing with. And then from that, I have some different questions. So I want you to read it, pause, think, and then listen to my answer, okay? Don't just plow through. So please pause and read this and come back when you think you have an answer. Okay, so the idea is you could look at the formula or you can just think it through. Let's think it through a little bit. So after they collided, okay, after they collided, the photon lost some energy, right? And so if it lost some energy, the way that I think about it is that means that since E equals hc over lambda, if this goes down, that means this goes up. So the wavelength must have increased. And so if it was changed by exactly one Compton wavelength, then I think of the new one as being equal to this. Okay, so this is what we started out with. This is the 6 times 10 to the negative 12th. This, they gave it to us. This is 2.43 times 10 to the negative 12th. And if you add them together, you get 8.43 times 10 to the negative 12th meters. And that's what this answer is. Okay, that's the first part. I'm going to the second part. Same thing. I want you to pause, read, think, do, come back. Okay, so welcome back. What's the angle of deflection? Well, this one we go to the formula. So lambda prime minus lambda equals h over mec 1 minus cosine theta. And if you did the math again, or you just could look at this, right? The difference in these two is h over mec equals h over mec 1 minus cosine theta. That means, right, 1 equals 1 minus cosine theta. Hopefully you see that. That means cosine theta is 0. When is cosine theta 0? Think, be careful. That means theta is 90 degrees. Shame on you if you thought 0. Okay, so that's that part. Same thing. Think about this. Solve for it. Pause. And welcome back. Okay, so the idea is that we're looking at energy. So I'm going to look at it this way. This is the conservation of energy, right? Photon before, photon after, kinetic energy of the electron afterwards. Another way to think about this is hc over lambda equals hc over lambda prime plus that kinetic energy. And we're solving for that kinetic energy. So hc of 1 over lambda minus 1 over lambda prime is that kinetic energy. hc, you know, is 1.24 times 10 to the negative 6 EVs times meters. And this is going to be 1 over 6 times 10 to the negative 12th minus 1 over 8.43 times 10 to the negative 12th. And I got 59,600 EVs. The book I took this from got 69,700 EVs. Not quite sure where. See if you can figure it out, but that's all I got. Okay, I'm going to try and save this.